Hi friends, welcome back to your channel. In this channel, we try to solve the previous year's physics question papers of Neet undergraduate exam. This is also helpful for those who are aspiring for JEE mains. This is solved in a very student friendly manner so that you can understand and apply the concepts. We have included all types of questions appearing in the exam so that your preparation is complete. If you like the content, we urge you to like the videos and subscribe to the channel so that it motivates us to create more content. We also urge you to subscribe to the channel so that you are immediately informed of any additional content added to the channel. If you have doubts, then please feel free to add in the comment section and we will revert to you at the earliest possible. So without much ado, let's get started. So in the previous video, we had posted around 12 questions on rotational motion, and we had subsequently also, we had solved 7 questions out of this, right, in the previous video. So you can have a look at those questions. You can have a look at the questions. So now we will solve from question 8 onwards, okay, till question 12, okay. In this question, it is given that there are two disks rotating about an axis, right? So if you look at it, right, there are two disks here, disk 1 and disk 2, which are rotating about the same axis, means their axis is the same, they are coinciding, right? So they are rotating about their axis, which is normal to the disk and passing through the center of the disk. For disk 1, it is given that disk 1, okay, the mass is equal to 4 kg, okay, the radius equal to 0.5 meters, and initial angular velocity is equal to 50 radians per second. What about disk 2? Disk 2, it has a mass of 6 kg, okay, radius of 0.2 meters, and angular velocity is equal to 100 radians per second. Now it is given that these two disks are now brought together in contact face to face, keeping the axis of rotation the same for both disks. So what is the final angular velocity? So initially these two are separate, so they had the separate angular momentum. Now when they have come together, so the total angular momentum will be conserved. We need to find that what will be the angular velocity of the combined system wherein both the disks are attached. So in this case, there is no external force being applied here. So we can assume that the angular momentum will be conserved, right? So angular momentum is same, okay. We can say this is conserved, right? So what is the initial angular momentum of these two disks, for example? See, these are disks here, so we know that for disk I is equal to mr square by 2, right? So this formula we should know, okay. So for disk 1, right, what is what is the angular momentum? L is equal to I omega, okay. So this is equal to I is 4 into mr square by 2, right, 0.5 square by 2, and omega is given to be 50, okay. So this will be 250 100, and this is equal to 100. 0.5 whole square is 25, right? So it is 25. What about the second disk? For the second disk, it will be again the same thing. L is equal to I omega here. If this is L1, I can say that this is L2 here, okay. So I again is mr square by 2. What is the mass of this one? Is 6. R square is 0.2 whole square by 2 into 100 is the omega. So this becomes 3, okay. 3 into 0.2 whole square is 0.04, okay. So 3 into 0.04 into 100, okay. This becomes equal to 300 into 0.04. This will become 12. So what is the total angular momentum, so this is equal to 25 plus 12 is equal to 37. Okay. Now, so this angular momentum will remain the same. So when the two disks are combined, so they have the angular momentum L is equal to 37. Total I individually. So I in the first case it was mr square by 2. So this is equal to, for the first disk it is 4 into 0.5 square by 2. This is 2 into 0.25 into 5. This is 0.5. Okay. And for the second one, for the second disk, I for this is equal to, for disk 2, I equal to 6 into 0.2 square by 2, right? So 3 into 0.04, this becomes equal to 0.12. Okay, so now this total angular momentum, this is equal to I of the total system into omega. Okay, so 37 is equal to, what is total I then? 0.5, 0.5 plus 0.12, right, which is equal to 0.62. How did you get the 0.5 plus 0.12? The 0.62, we got this, right? So this is equal to into W. So let me just calculate here itself. So W is equal to 37 by 0.62, which is roughly equal to 60. Okay, so this is the answer. So if you look at the options given to us, so look at option C, that will be the answer there. Let's go to the next one now. A man moves in a circle of smooth horizontal plane. A mass moves in this thing, right? So imagine this mass is moving here. This mass is moving this has a radius r1, right? So, and how is it here? There is string attached to it. So the string you can see here, right? The string is going and it is being attached to a small mass. This is m. Okay, so this is the mass m to which the string is attached. This is a string here which is attached here. Okay, so now the string is attached here. It passes through the smooth hole, correct? It passes through the smooth hole and it comes on top of the plane. The tension is increased in the string, and finally m is moving in a smaller radius, right, which is 1 by 3. If initially it is r, now the radius is 1 by 3 r1. Okay, so what is the ratio of the final kinetic energy of the mass to the initial kinetic energy? Okay, so again here also we are not adding any additional extra force here, so the angular momentum once again it will be conserved, right? Angular momentum is conserved. So if the angular momentum is conserved, then the initial angular momentum which was there, then that will be the same as the final angular momentum. Now, when the disk was, when it was rotating like this, when the mass was rotating like this, then what was the angular momentum here? I can say L1. This is equal to m. It was moving with the velocity, say v1, and its radius was r1. So this was the initial angular momentum mv1 to r1. Okay, and in the second scenario, when rotating with a smaller radius, what is L2 in that case? Again, the mass remains the same. Okay, the velocity is actually not, the velocity obviously will not be the same, right? It will got changed here. So I'll write v2, and the radius r2. This is the 1 by 3 r1. Okay, 1 by 3 r1. Okay, so since the angular momentum is conserved, I can say that this is equal to this one. Okay, so mv1 r1 is equal to m v2 to 1 by 3 r1. So r1 gets cancelled, m gets cancelled, so it means v2 is equal to 3v1. What do we need to find here? We need to find the ratio of the final kinetic energy to the initial kinetic energy. So what is kinetic energy? All of us know that Ke is equal to half mv square. This is in general, this is the formula here, right? So initial kinetic energy, what would have been there? Ke, like to say Ke1 is equal to half m into V1 square. Okay, V1 square. And what is this final K2? Which is the second latest kinetic energy, half m into V1 square. So now this becomes V2 square. Okay, and we know that V1 V2 is equal to 3V1. So this becomes half into m into 3V1 square. Okay, this becomes equal to half m to 9 V1 square. So what is the ratio of K2 by K1 there? That is what the question expects us to find out, right? This is equal to half m into 9 V1 square divided by half m into V1 square. So this equals to half m, and V1 square gets cut. So it's equal to 9 is to 1. Okay, so this is the answer. Now we go to the next problem, right? In the next problem, similarly, it is given here that a circular disk of moment of inertia I, okay, is circular disk of moment of inertia I rotates in a horizontal plane about its symmetrical axis with a constant. So d1 has a moment of inertia is equal to I1. Okay, and this should be I1 actually. So I think there is a typo. It's I1. Okay, and if we write properly, so we will not be able to find out. So this should be actually equal to I1. Okay, so the initial disk has a the first disk has a moment of inertia I1, and its angular speed is actually W1, for example. Okay, the second disk has a moment of inertia I2, and it also has a speed of W2. Okay, right? So now these two are combined. Okay, these two are combined, and this W2 is given to be 0. If these two are combined, we need to find out that how much is the energy lost by the initial rotating disk due to the friction. Okay, so now let's look at it, right? So again, we'll apply the same principle of angular momentum conservation. So what is initial angular momentum of disk 1 is I1 into W1. Okay, disk 2, the angular velocity is 0. Okay, so this plus 0, and what is the final angular momentum? It is equal to I1 plus I2 into WF, right? So WF is given to be the final angular speed. Okay, so this, right? So it means WF is equal to I1 Wn 1 upon I1 plus I2. So let's remember this now. We need to find out that what is the energy lost by the initial rotating disk due to the friction. So energy, what is energy lost here? This is kinetic energy, right? Because the first disk was actually rotating with a certain kinetic energy, rotational kinetic energy, but because of coming in contact with the second disk, due to friction, the angular speed would have reduced, right? So in that case, what was the initial kinetic energy? Initial kinetic energy was equal to half into I1 into W1 square. Okay, the final kinetic energy it will equal to half I1 plus I2 to WF square. Okay, so what is the change in the kinetic energy? Change is equal to, so now the initial kinetic energy and the final kinetic is something would have got lost in friction, right? That is the question here. So it means initial kinetic energy would have been more than the final kinetic energy, right? Is equal to half I1 W1 square minus half I1 plus I2 WF square. Okay. So now this one we can also write as half I1 W1 square minus half I1 plus I2. What is WF? WF we know it's I1. This is I1 W1 square. So this is I1 W1 square divided by I1 plus I2, the square of this also, right? So what will happen then? This get cancelled now. So this we have now half I1 W1 square minus half I1 square W1 square upon I1 plus I2. Okay. So now let's take half I1 W1 square as common, right? So is equal to half I1 W1 square. We'll take this as common. So we are left with 1 here, 1 minus, and we are left with I1 upon I1 plus, I1 plus I2. Okay. So let's focus on only this one, right? Let's leave the outside part of it. So 1 minus, I1 upon I1 plus I2. This is equal to, I can write, we can take LCM as I1 plus I2, and this becomes 1 into this thing, right? So this becomes I1 plus I2 minus I1. Okay. So this gets cancelled. So we are left with I2 upon I1 plus I2. So now let's add this back to this, right? To this equation. So this becomes equal to, we had outside, we had half I1 W1 square, okay, into, we'll get this one now, which is I2 upon I1 plus I2. Okay. So this will be the answer. Okay. So basically it is half I1 I2 W square upon I1 plus I2. So if you look at these answers which are given to us, the D is the answer. Okay. So answer is D here. Okay. Now let's go to the next problem now. In this question, it is given that there are 2 point masses M1 and M2, right, which are at the opposite end of the rod L. Okay. So imagine that this is the rod here. This is a rod here having the length L. Okay. And we have this A. So what do we need to do here? There are 2 point masses M1 and M2. Okay. This is a point A. Okay. The rod has to be set rotating about an axis perpendicular to it, right? So if this is the axis here, so it has to be made rotating around this axis. Okay. So we need to find the position of point A on this rod through which the axis should pass. Okay. The axis should pass. So the work required to set the rod rotating is minimum. Okay. So this has to, so we need to perform some work on this, right? So as to make it rotate. If it rotates, it will acquire kinetic energy, right? So it means, what is the kinetic energy? What is the kinetic energy it will acquire? So Ki, which it will acquire, or it will gain kinetic energy, this is equal to half I omega square. Okay, right? So, and what is I in that case? I is equal to, if this is M1, and imagine that if this is X from here, okay, and this is L minus X, okay, so we have to take them as two separate entities, right? So because of M1, what is the moment of inertia? It will be M1 X square, okay. Because of M2, what will be the moment of inertia? It will be M2 into L minus X whole square. Okay, so we have to perform some work on this, and that work will get converted into kinetic energy, right? So what will be the total kinetic energy in that case? So Ke becomes equal to half, okay, this is the I here, right? So I can write M1 X square plus M2 L minus X whole square. This is the I part of it, right? And this is into W square. You can also write it as half W square m1 square m1 x square plus m2 to L minus x whole square. Okay. So this is a kinetic energy it will require. And how does it get the kinetic energy? Because we have performed some work on this by rotating this, correct? So this is the work being performed. So this is the work. So if the work has to be minimum, it means this particular expression, it has to be minimum, right? So it means for that to happen, we know differential calculus. So because how in differential calculus, if dw by dx is minimum and is equal to 0, then it means that it could be a maxima or a minima. Okay. So dw by dx is equal to, we have to differentiate this part, right? So basically I'm saying that d dx of this entire thing, right? Half omega square into m1 x square plus m2 L minus x whole square. Okay. So we need to differentiate this, right? So this becomes equal to, so d dx of this half omega square remains constant, remains outside. Okay. m1 x square, if we differentiate this part, this becomes 2 m1 x. Okay. If you differentiate this part, this becomes 2, the 2 will come down here as a coefficient 2, m2, and L minus x, this power will reduce to 1, L minus x, and because the coefficient of x is minus 1, when you differentiate this, this will come into minus 1. Okay. So we can say that this is the, so this is dw by dx. Now this has to be equal to 0, right? If this has to be equal to 0, now w is a constant, right? It's outside, right? This is not going to change with x, for example. So we need to check that this particular expression, when will it become 0? It means 2 m1 x, this minus 1, we are multiplying this, so this minus will become here minus 2 m2 into L minus x. Okay. So I can say that okay, so we can say that 2 m1x is equal to 2 m2 L minus x. So we can say that 2 m1x, so I can actually the 2 I can cancel it, right? So 2 if you cancel it here, so I can cancel it here. So this becomes m1x is equal to m2l L minus m2x. Okay. Or we can say that if we bring this x on the left side, m1x plus m2x is equal to m2l. Okay. This implies that if you take x on the, if it takes x as common, x is equal to m2l upon m1 plus m2. Okay. So this will be the value of x. Okay. Now let's go to the next problem now. So in this question, the answer will be m2l upon this thing, right? So if you look at the first option, that will be the answer here. Okay. Let's go to the next problem now. A constant torque of 1200 kg meters. So the torque is given to me as 1200 kg meters. Okay, 1200 kg meter. It turns a wheel of moment of inertia I is equal to 150 kg meter square. Okay, right. So its center, the wheel starts from rest, so initial angular velocity W0 is equal to 0, right? What is the angular velocity after 4 seconds? Now, if imagine if this is the wheel here, if you make it to rotate, around a certain like this, right? So then initial angular velocity is 0, but after rotating for 4 seconds, it will acquire some angular velocity because of a certain acceleration, right? Now, how will I get the acceleration? So we know that tau is equal to I alpha. We know that. So what is alpha then? Alpha is equal to tau, which is 1200 divided by I, which is 150. This becomes equal to 8. Okay. So we know that omega is equal to omega 0 plus alpha t. Omega 0 is 0, alpha is 8, we just now found alpha is 8, and we are taking 4 seconds, right? So this is equal to 32 radians per second. So this is the answer. Sorry. If you look at the options given to us, the option is the second option. Okay. So friends, with this we have solved all the questions of rotational motion in this video. I hope you are liking the videos and you are learning from it. And if you're learning from it, we'll request you to please like and subscribe the channel so that it motivates us to create more content. Okay. So we will post another set of questions after this video. Okay. We'll request you to keep practicing this. And if you have any comments, please post it in the comment section so that we will revert to you shortly. Okay. So with this, we'll end the video. Thank you.